Hello, we are looking at significant figures today and how to determine exactly what is significant and what is not. Now, take a moment to think of the word significant. What does that mean? Well, if something is significant, then it has a very particular meaning. It is of some importance. When we are measuring, there are limits to what we can measure. We cannot measure things down to infinity. So significant figures allow us to kind of mentally set limits for how precise we are talking about. They're quite often used in science, but they're also very important in mathematics as well. Let's go over some rules of how to know when numbers are significant so you can count and determine how many significant figures there are in a number. First rule, all non-zero numbers are significant. So if you have the number 22, well, you've got two digits right there that are not zero. So there would be two significant figures. I'll just say SF for right now. That is shorthand for significant figures, not for San Francisco, not this time here. If you've got the number 147, how many significant digits are there? You would have 3 significant figures. And pardon me, sometimes I say significant digits. The two things are basically interchangeable. If you had 100, let's do 1,000. Let's do 10,000 and or 11,001. I'm sorry. How many significant digits are there? Oh, we don't know for sure yet because that leads us into our next rule, which is zeros between non-zeros are significant. So going back up to this one right here, 11,001. Based on our previous rule, we know that the first, second, and fifth digits are significant figures. And our new rule says that these guys are here too. So in this case, 11,001, you have 5 significant figures. If you've got the number 7,012, how many significant figures do you have? That would be 4 significant figures. Because, again, Rule 1 says that these guys are all significant figures because they are non-zeros, and the 0 is between other significant figures. Okay. Let's say we've got a situation like this. 120. How many significant figures do we have? Well, zeros to the left of a decimal point are significant. Let's zoom in on this 120 again. So this is going to sound very strange, but is there a decimal point right there? No. Since there is not, then this 0 in this case is not significant. And I'm sorry, 0, you probably feel sad about that, but that's okay. You have to deal with what you are, 0. I'm sorry. We all have our challenges. You will be all right, 0. 120. There is no decimal point. So in this case, we would have 2 significant figures. Yet, if we had I won't say the exact same number, but if we had 120 and we added a decimal point right there, that changes the numbers significantly, if you will. Sorry for the pun. Now you do have 3 significant figures, because the rule says any zeros to the left of the decimal point are significant. So this would be 1, 2, 3, 3 significant figures. If you had 1200, oh, I'm sorry, I'm getting ahead of myself here. If you had 1200, then how many significant figures do you have here? 1, 2, 3, 4. Both of these now are significant, of these zeros, because they are to the left of the decimal point. What about if we had something like this? Let me get a little bit of space. Whoop. And let's say we went back to 120, and now we added a 0 after the decimal point. How many significant figures do we have here? Well, our last rule is zeros to the right of a decimal point are significant, always. Always. So if we had 120.0, how many significant figures do we have? Well, we saw from before that these first 3 will be significant, and now this additional one is also significant, which means we have 4 significant figures. When you're using these in science, basically it's a way of saying that, and in math too, but this is how far I can measure accurately up until. This is how much I know for certain. Because even if you are using a ruler which has millimeters, you cannot use a ruler. You know, if you look at a ruler, here are the little millimeter marks, and they are quite tiny. You can't measure any smaller than that. So if you're measuring in millimeters, you can say something that's like, oh, 7 millimeters or whatever. But you can't say it's like 7.2 millimeters because there's no 0.2, like millimeter markings. Those millimeter markings are not broken up further into 10. So there's a limit. And the significant figures allow us to say, kind of built into the number, this is how certain I can be and to what level my measurement is accurate to, because that accuracy is very important. Going back to our rule again, that zeros to the right of a decimal point are significant. If you have something like 17.04, how many significant figures do you have here? Well, going back to our first rule, remember that says that the 1, 7, and the 4 are all significant. And for a number of reasons, so this 0 is between 2 non-zeros, and it's to the right of the decimal point. So this one will definitely be significant as well. So we're going to have 4 significant figures. Going back to this guy again really quick, our first one, that means that if you have 120 decimal point, this has 3 significant figures, and if you have 120.0, how many significant figures does the second one have? This has 4. Because, again, our last rule says that this guy is going to be significant there as well. So, even though they may look like they are the same number, the amount of significant figures tells us how accurate our measurements are and how reliable we can count on something being as close to this number 120 as possible. Really, again, significant figures, since they're telling us how accurate our measurements are, basically beyond this stuff, we don't know what's here. Maybe there's, we cannot zoom in on the atomic scale. We are not Ant-Man, and we can't get super tiny yet. Maybe that's like some science that you can do in the future. I don't know. Maybe it's possible. It could be tough, though, so good luck with that. So those are the rules for significant figures. Please review if you have any questions. Please, of course, bring in your questions so that we can talk about them. And I believe this will be quite useful to you for a very long time. So have a great day.